Let's take a look at what we call the forward start options. A forward start option is an option that it becomes effective or started at a future time t1. You are currently at time 0. The actual starting time of the option is a future time. Now the maturity of that is, t2. Well, when you really think about it, what's the point of having a forward start option? If we can determine the strike price now, then there isn't any difference between a forward start option and a regular option, because you can call it started at this point, but if you know the strike price in the contract at time t, it doesn't matter. So this value, you call it when it starts, as long as it's between 0 and t2, it doesn't change anything. So for forward start options to make sense, then it must be the case that we don't know this strike K currently. This strike K is only determined at this starting point T1, okay? Because otherwise, then there's no difference between a forward start option and a regular option. Okay, and typically for a forward start option or forward start call put, where the strike is set at T1 to equal to the realized stock price at this point here, T1. So basically, a forward start option is an option that we can have a contract now, but it's an option that in the future that is at the money at a future time T1. Okay, by design, it will be an at the money option, and that option is only at the money at a particular time we desired, which is, we can set it in the contract, say T1. Okay. So let's take a look at how we're gonna price a forward start option. To price forward start options, the key insight is that this condition must be true. So what is that? Well, basically, we're saying that, say for example, there are two realizations. One is scenario A, and the other one is scenario B. So in scenario A, obviously, there's some realized price as A. So 1 here means the forward starting time 1 here, okay? So for both scenario A and scenario B, they are all they're the realized prices at this time 1, T1. So this is what 1 means. But in scenario A, we have S1A, and associated with S and A, there's a K. And K1A is obviously equal to S1A. And because of this, realized S1A, there is a price of C1A, okay? And for scenario B, there must be a realized price of S1B and an associated K1B. And this S1B then drives the price of C1B. Now, if you think about it, if you are already here, right? So you are, from here, time has already passed to this point. And this would just be at this point, the forward start option would just be a regular option for any realized stock value that you have at that point, okay? So let's see why this is the case. Because the thing here is, at T1, your forward start option just becomes a regular option, regular at the money option for whatever realized stock price you have. Now you see that for a forward start option at the T1, S1A must equal to K1A and S1B must equal to K1B. Now, and also that at this point, the option is just a regular option. So we can use the formula to price that as well at time T1. So this will be the pricing formula at T1. But because this is basically just a regular simple option, for this will be the call price, Black-Scholes call price. Now, because S1A is equal to S1B, so S equal to K, sorry, S1A is equal to K1A, so S is equal to K always. Whether it's a scenario A or scenario B, we always have S equal to K. So therefore, it doesn't matter which scenario, D1 is always a D1. So a different scenario will still have the same D1 if we have a forward start option, because the design is that it's at the money option. And similarly, D2 is equal to, for scenario A is equal to D2 for scenario B. So they're the same. Now, if you just plug in the regular formula here, because S and K are the same, so you can may as well just take the common terms here. So rearrange, you have a term like this. And whatever in the bracket for scenario A and scenario B, they're the same. So therefore, we have the ratio between the C1A, which is the price of the forward option if scenario A materialize, divided by the price of the call option if scenario B is realized, is equal to the ratio of the stock price that's realized in A and the stock price that's realized in scenario B, okay? So we have derived the condition we're looking for. And let's see how this condition will help us to price this forward start option. Now, if we have this condition been true, we can, we're not saying, A and B is any, they can be any scenarios that we have, right? So that's just for the sake of argument, we can always, use scenario B as a scenario that the realized price is equal to the current price that we have seen at time 0, right? It could be any price, so we can say we force this to be a particular price, because this condition will be true for any price. So we can force this condition to be the case that, this S1 scenario B is the scenario that the realized price is just the currently observed stock price. Now, if that is the case, we can substitute this S1B to be S0. And basically, the call price, if scenario A is materialized at time 1, would just be this call price if scenario B is realized, which in this case is B is really the current price of stock, which we can express it this way, times this thing here, which is this. We just substitute it as for this, okay? So we basically have this condition here. So this condition here, if scenario B is S0, becomes this scenario, becomes this condition, okay? Now, we know that for a call price at time 0 at this point, What is that? Well, the call price times 0 is really the discounted value of the call price at this point, given some scenarios, right? And so now, what is a scenario at time 1? Well, we'll say the call price, the realized call price at time 1 is governed by this condition. So we can substitute it in of the call price that is realized at time 1 if the current stock price is realized times this whatever price. This is random. This is a random price, right? Based on some scenario A, right? So, but this S naught is not a random price, is the realized price that we currently see. So because we have S naught, this part is actually not it's no longer random because we can price it this way. This price, if the realized price at time 1 is S naught, this C1 S naught, which is the realized price of scenario B, is realized, which is scenario B being the current stock price is realized, is this value here, which we can calculate, which we know what that value is based on the Black-Scholes formula. So this is not constant. So this call price is not a constant. This stock price is not a constant. Sorry, this is a constant. This call price is a constant. This stock price is a constant. The only random variable here is this S1A. And we're taking expectation of this, okay? And discount it back. And we can get the current call price of the forward starting option, of a forward starting call. Okay, so if we do expectation here, we just pull them out because they're constant. So they have this value divided by S naught, you can just pull them out. What we have here is, now if you derive that, you pull this out, and what's the expected value of this S1A? Expected value at time equal to T1 is really the current price times e to the power of r minus q T1. So this is the risk neutral expectation here. Okay, so we know this, we can plug this in. Obviously, the S naught will canceled, and will be this C1 S naught, which is the price of scenario B, times this part here, e to the power of r minus q times T1. And this C1 S naught, we know that is equal to this. So we put everything together, substitute here, and rearrange. We will have this condition here. Will give us the price of a forward start call. And if we have the dividend yield being 0, and say the stock doesn't pay any dividends, then we will see that actually the forward starting call would just be the same as a call that with the realized price at T1, which is equal to S naught. You can do this for a call. You can equally well using the same approach and to price a forward start put as well. And I'm gonna leave it as an exercise to the class to do that. So make sure you try it out and you are comfortable to derive its formula.